An overview of a survey of 3D printing's impacts on accessibility in education. In this presentation, we're going to go over a few key concepts that we've pulled from the current body of knowledge. We're going to go over the proposed case study and some data analytics collection proposed from that case study. And we're going to conclude with the direction of research and future research possibilities. In the current body of knowledge, we find three major areas that we want to talk about inside of this presentation: the supplemental materials, the 3D printed artifacts, and the current barriers. These are intertwined throughout the body of knowledge and throughout the research presented in this paper. The current supplemental materials that are provided for accessibility to students are subpar. Most of those resources are translated by non-subject matter experts and are typically translated incorrectly in relation to the information that is provided to non-disabled and non-impaired students. By bringing 3D printed artifacts into the educational course, we're working to change this problem. But there are some problems as it sits with 3D printed artifacts. When 3D printed artifacts were originally presented as part of supplemental materials, a lot of those 3D printed artifacts were in a binary state with a raised edge and a lowered value. This really didn't provide true representation of some of the values that needed to be represented that students that were non-impaired were getting. We weren't able to show curvature. We weren't able to show gradation. We weren't able to show impact or severity with these particular 3D artifacts. In addition, these 3D artifacts typically weren't made to be transported. They were expensive and they stayed with the instructor, professor, and lecturer. So if a student needed to revisit that artifact, they would have to come back to the instructor to reacquire that artifact in the instructor's office typically. By bringing new 3D printed materials with 3D printing to this space, we're able to provide low cost, highly durable, and more exact information to students, and they're able to take those artifacts with them, increasing their ownership and investment in the educational process for which that artifact was designed. By taking these 3D printed artifacts and giving the ability to the instructors and professors and lecturers to design these artifacts because they are the subject matter experts and they know the information that they're trying to convey to their students, we are providing them a better use of accessibility for their uh, disabled and impaired students. Some current barriers to this, however, are the familiarity of the applications and the familiarity of 3D printing with the educational body, the lack of 3D printing templates available to these educators for the curriculums that they're trying to provide accessible material for, and the general accessibility of this across social demographic barriers. In this paper, after the literature review, we're proposing a case study for a survey level CS course, wherein which we will provide 3D printed instruction, support, and materials for the instructor to incorporate 3D printing artifacts for accessibility for not only the impaired students and the disabled students, but for the non-impaired and disabled students as well. The susp- the purpose of this case study is to try to determine if adding 3D printing into these survey level courses will increase student retention and progression by giving the students ownership and additional tools to engage the student in the educational experience. Some data points that we're expected to collect and review are going to be collected through surveys. The surveys will be developed through a collaboration with Center for Teaching Excellence and Learning, Quality Matters experts in the fields of the College of Computing Science, and the IRB review process. Um, we are intending to provide these surveys to the students for one term of the CS course. Currently, that's approximately 600 students. When we receive the information back, we are intending to review the analytical data through uh, systems such as Tableau and SPSS. The qualitative data is going to be reviewed manually and sorted into categories to provide a normalization of that data in reference to the outcomes of the case study in regards to student progression and retention. In closing, um, as this is the beginning of this paper, we are intending to pursue the research questions of how does 3D printing technology in a classroom or curriculum impact student retention and student progression. There are also areas of research that are opened up by the body of knowledge to include the ability for us to find ways to cross the social barriers and economic barriers to provide um, 3D printing and open educational resources to different areas in the country. There have been some research done in institutions across the U.S. where they are using 3D printing to um, provide courses to underserved populations that would normally not have been able to participate in those courses. For example, providing 3D printed data analytics for heat map syncing on crisis events for students who are visually impaired or blind in a coding or CS environment.